this clip, we're going to be talking about the concept that you either have already learned or are about to learn in your calculus courses, something called the product rule. And basically, this is where if you have some h of x and you're able to have it split into two different pieces, call it f of x times g of x, then we would like to have a convenient way to take the derivative of h of x, but we don't really have a tool for that we can use with just adding it or breaking it apart or anything like this. So we are not able to figure out what ddx of h of x is in a traditional way, like the sum rule of differentiation, where you can just break it apart and do it individually. That's not gonna apply here. So we're gonna have to come up with a completely different approach for this one. So, okay, let's call a function y, and let's say it's f of x, or let's use the u times v convention again. So this equals u times v, or rather u of x times some v of x. So now let's put this down here as u, or as y equals u times v for the sake of convenience. And now let's add in our infinitesimal pieces and see what we can do with it. So y plus delta y equals the quantity u plus delta u times v plus delta v. We'll notice we can just multiply this out. So y plus delta y equals, the first term is u times v, plus outside is u times delta v, plus inside is v times delta u, plus the last is delta u times delta v. But notice how here we set our y equal to u times v initially, so having a y on one side and u v on the other side, we can just cancel that out, and we're going to have to get this into delta y over delta x form. So let's divide the whole thing by delta x. So rewriting this, we're going to get delta y over delta x equals u times delta v over delta x plus v times delta u over delta x plus some delta u times delta v over delta x. Now what can we do? We'll recall from earlier that the limit as delta x approaches 0 of some delta y over delta x is how we come up with dy dx, or the derivative of y with respect to x, because we care about finding some equation that can describe anything that we want to, assuming some infinitesimal change. That's what the derivative is. So let's go ahead and apply this to every piece. So limit of delta x approaches 0 of delta y over delta x equals u times the limit of delta x approaches 0 of delta v over delta x plus v times the limit as delta x approaches 0 of delta u over delta x plus limit as delta x approaches 0, and this is just a bunch of infinitesimal pieces, so let's go ahead and just group that. So delta u times delta v over delta x. So now we need to go ahead and evaluate this, but fortunately for us, this puts us in the dy dx form that we want to for every piece. So this goes to dy dx equals u times, notice that if we just change the variables around to fit our situation here, this is going to be u times dv dx plus v times du dx. And then notice how here, if delta x approaches 0, then delta u also approaches 0, because the changes are all going to be infinitesimal. So this is really like saying plus u times dv over dx, but 0 times that piece, that's just going to go to 0. So really what we're left with is dy dx equals u times dv dx plus v times du dx, but also, if you recall, we had y equal to uv earlier, so d of u times v dx equals u times dv dx plus v times du dx. And this is how a lot of your textbooks will present the product rule to you. This is basically like saying the derivative of some y that can be represented as u times v with respect to x equals u of x times the derivative of v of x with respect to x plus v of x times the derivative of u of x with respect to x, with respect to x being that x is the variable, not a constant. So when we're taking derivatives, we need to know what we're taking it with respect to, because taking the derivative of a variable versus a constant are two very different things. So you're going to be using this a lot on your exams and your homework. So hopefully you found this helpful, and come back for the next one where Joe shows you how.